studied about rules for the construction of the root locus. Then there is one topic, that is root locus concepts, that is same as whatever we explained in rules of the rules for the construction of the root locus, same thing. So I'm not repeating that for simply it will confuse you. So we mainly concentrate how you can solve or how you can draw a root locus of a given open loop systems of a given system. Now before we are going to start, we will some clarifications we need to do. Now just we'll take one simple example. Consider the example of feedback system shown in figure 6.3, that is g of s is equal to k into s plus a divided by s into s plus b, and h of s is 1. Now you can see that here there are two poles and 1 0. The characteristic equation is 1 plus g of s into h of s, that is 1 plus g of s is equal to 0. Now, so here angle criteria for the root locus is, here already we know that at s is equal to 0 there is a pole, and s is equal to minus b another pole, s is equal to minus a 1 0. Now the angle criteria, angle of g of s h of s is equal to s plus a divided by s into s minus a, that is equal to plus or minus 2q plus 1 pi, q varies from 0 to 1 2. Now s is equal to sigma plus j omega. S is a sigma, we have to substitute in this. S plus a divided by angle of s plus a divided by s into s plus a. There, wherever s you should submit sigma plus j omega, then plus a. Here sigma plus j omega. Here sigma plus j omega plus b. Okay, and this numerator, when you are finding the angle, numerator and denominator terms will come as a negative and the numerator terms comes as positive. So the angle is normally tan inverse of imaginary divided by real. That means tan inverse of omega divided by sigma plus a. If you come to the denominator, it will become negative, that is minus tan inverse of omega by sigma minus again tan inverse of omega divided by sigma plus b. Since we are having two poles, here we will take it as minus pi. Okay, so this ultimate, you can say this maximum value of this will be pi, and this will be again minus pi, pi and minus pi will be cancelled, so minus pi remains. That is why you can consider this as minus 5. Now we are doing the rearrangements. This minus 5 you can take it, this minus 5 you can take it this side, and what are the negative terms you can take it to the other side. So you will get it as tan inverse of omega by sigma plus tan inverse of omega divided by sigma plus b is equal to pi plus tan inverse of omega by sigma plus a. Now taking tan on both sides. Okay, so if you are taking tan a, if you are taking tan on both sides, yes, you will get tan of this you consider as a plus this consider as b, then tan a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. By using that formula, you will get tan of a. This will be tan inverse of w by omega, it will be w by omega, tan in plus tan inverse of omega by sigma, that is omega by sigma plus b, divided by 1 minus tan A tan B, that is omega by sigma into omega by sigma plus B. This side you will get tan pi plus omega by sigma plus A divided by 1 minus tan pi into omega by sigma plus A. And you know that tan pi is 0, so you will get it as this side is omega by sigma plus A. So this, if you are rearranging, you can take sigma into sigma plus B as a common term. So omega into sigma plus B plus omega into sigma divided by 1 minus, this sigma into sigma B will go to here, sigma into sigma plus B minus omega square, and sigma into sigma B, numerator and denominator will be cancelled. So you are getting it as sigma into sigma B, sigma plus B minus omega square. You can do it. This will be, you are multiplying by this. So here sigma into sigma B minus omega square divided by sigma into sigma B. Here you have to take the common term as sigma into sigma plus B. So this will be multiplied, this will be multiplied by this, and denominator, both the denominator terms can be removed. So you are getting like this. Okay, so this is equal to omega divided by sigma plus A. Now if you are expanding this, this will become omega sigma plus omega B plus omega sigma. So you will get 2 omega sigma plus omega B. Okay, so and denominator you will get sigma square plus sigma B minus omega square, this sigma plus A. Numerator you can take omega as a common. So omega into 2 sigma plus B, and this side also omega, so that omega can be cancelled. So you're getting like this. Now okay, so this you have to do the cross multiplication. 2 sigma square plus 2 sigma A, then B sigma plus BA is equal to sigma square plus sigma B minus omega square. Now in this you can see that sigma B you can cancel. Okay, sigma and 1 sigma, sigma B you can cancel, and here 1 sigma sigma square, that also you can cancel it. So here net effect will be sigma square 2 sigma A, this omega square you can take it here, is equal to this minus AB. Now in order to complete this as a second order expressions, or sigma plus A square, you need a square here. For that, one A square you have to add it here, and here also you have to add it. So you will get sigma plus A square plus omega square is equal to A square minus AB, that is equal to square root of A square minus AB all square. So equation 6.4 is the root locus of 6.4 is the equation for the root locus in the S plane. It is a circle centered at, this is the circle equation. It is a circle centered at minus a comma 0, that is at 0 of the open loop transfer function, and radius 0 of the open loop transfer function, and radius minus a square minus ab, minus a square minus ab, radius ab. The root locus is shown in figure. So this is a this will show a equation of a circle with the radius square root of a square minus b, and the center of the circle is at minus a comma 0. So you can just refer the circle equations. Now when you are drawing like that, you are having here you are having one pole at 0, another pole at b, 1 0 at minus a. Now as per the rules, the root locus, you found that it is a circle with the center of minus a comma 0, and its radius is nothing but square root of a square minus ab. So you are drawing a circle. And another important thing is that which all the as per our rules, we are not doing this systematically, we are following the rules in this problem, but later next problem or we will see that. You can see that normally the root locus starts at poles and it will end at 0. Now you are having two poles, it will be started again. When you are considering the segments, when you are considering the second between minus a and minus b, this segment, okay, the segment between minus a and minus b, if you are counting the sum of poles and zeros, you can see that there are two poles. It is not an odd number, so this segment is not a part of this root locus. When you are considering this segment on the real axis, you can see the number of poles plus zeros equal to 1, 2, 3. That is 3. It is an odd number. So this is included in the root locus. Okay, and the segments here, between b and 0, you can see that right of this there is one pole, so odd number of poles or 0 is there. So this root locus also, this segment also part of root locus. Now you can see that again as per the rules, here two poles and 1 0. So the root locus start from 1 poles and it will end at 0. But for another the root locus next branch start from next pole, but there is no specific 0 to terminate it. In that conditions, as per the rules, you can see that it will go to the zeros at infinity. So we'll start from 2 poles. The root locus is coming. Okay, one is going in this way, another is going in this route. It will come and combine here. One will go to minus a and another is go to minus infinity. So this is a simple example. Okay, so that's only I need to explain. And there is another topic in the syllabus, that is construction of root log. Okay, that is whatever things we explain, the same thing. Here the characteristic equations, then g of s, h of s, that is equal to k into sum of zeros, the s plus zeros divided by s plus poles, it is nothing but k into product of I varies from m s plus zi, product of j varies from 1 to n s plus pj. Now g of s into h of s is equal to minus 1. Magnitude of g of h of s is equal to 1. Angle of g of s into h of s is equal to plus or minus 2q plus 1 pi. So again, as per g of s, h of s, you know that is equal to 1. From this k is equal to, from this you can, k is equal to, this term will go up, this will come down. So k will be is equal to product of j is equal to 1 to n s plus pj divided by product of I minus 1 to m s plus zi. Now the sum of zeros, angle of sum of zeros minus angle of sum of poles is equal to plus or minus 2q plus 1 pi, and q varies from 0 to 1 to, and k is k, the k value at any point s naught on the root locus can be found by product of phasor length from s naught to the open loop poles divided by product of phasor length from s naught to the open loop zeros. So that rule number 9. So same thing, it is explained here. Now we will take a typical example as a very typical example. Here, draw the root locus plot for the rules may not be followed in the correct path, but I'll explain in this text it is not in the right path, but I may explain it in the right way only. So g of s into h of s is equal to k into s divided by s plus 1 into s plus 3. So this is an s. It is an open loop transfer functions. It is an open loop transfer functions. It is an open loop transfer functions. So here, when you are observing it, you can see that there is no zeros. There are 3 poles. Poles 1 is at 0, another pole is at minus 1, another pole is at minus 3. So now all the if there is a pole, there is equal number of zeros, but in this expression zeros are not there. In that case, the zeros are located at infinity. There are 3 zeros that are located at the infinity. Okay. So how the root locus travel, that decided by the asymptotes. Already I told asymptote is a straight line that approaches the graph, but it won't coincide with the graph. Approaches the graph in all time, but it won't coincide in a finite area. It won't coincide. So here, now as we discussed, as per the rules we will go. The first rule, the root locus is, you can see that root locus is is symmetrical about the real axis? Yeah, definitely it will be symmetrical. That we will see after the constructions. But here you can see that the poles, only you can see only poles, no zeros in this expression. Only there is no zeros, or only poles that are located on the real axis only. So we can say that it is symmetrical about the real axis. Now a second rule, each branch of the root locus originated from the open loop pole where k is 0 and terminated on the open loop 0 or infinity, or the 0 at infinity where k is equal to infinite. The number of branches the root locus terminating on infinity is equal to n minus m, that is number of poles minus number of zeros, that is number of open loop poles minus the number of open loop zeros. So here in this example there is no 0, so there are 3 branches that terminates at infinite, and the branches will start at s is equal to 0, s is equal to 1 and s is equal to 3. S is equal to 0, s is equal to minus 1 and s is equal to minus 3. Now the segments of a real axis formula, just 1 minute. Yes, yeah, no problem. Yeah, now when you are coming to the third the rules, segment of, yes, segments of real axis having an odd number of real axis open poles plus zeros to their right are part of the root locus. So that we will see here, we in this figure we located our all poles. One is at s is equal to 0, one is at s is equal to minus 1, and here s is equal to minus 3. Here this segment, okay, this segment on the real axis, segments on, just read it once more, the segments of the real axis having an odd number of real axis open loop poles plus zeros to their right are parts of the odd number of real axis open loop poles plus zeros to their right are parts of the root locus. So here when you are observing it, you can see that when you are taking this segment on the real axis, so to the right of this segment you can see that 1, 2, 3 there are odd number of poles, so this segment is included in the root locus. Now the segment between minus 3 and minus 1, you can see that here right of this there are 2 poles, that is even number, so this segment is not a part of the, this is not a part of the root locus. Now the segment between minus 1 and 0, when you are considering that there is a pole at the right hand side of this segment, so this is included in the root locus. So that is the third rule. And yeah, what will be the fourth rule? Fourth rule, the n minus 1 root locus branches that tend to infinity do so long straight line asymptotes, making angles with the real axis is given by theta q is equal to 2q plus 1 pi minus n minus m, where q varies from 0, 1 to till n minus m minus 1. So here the fourth rule, we have to get the angle of asymptotes. Here there are three poles. Okay, three poles, no zeros, but the matching zeros are at infinity. Okay, but here there are distinct three poles. Okay, so there are three asymptotes. That means you know that straight line very near to the real graph or root locus. So here as per the formula, theta q is equal to 2q plus 1 m n minus m. N is 3 minus m, that is m is 0, into pi, where q varies from 0 to n minus m minus 1. So n minus m is 3 minus 1, that is 2, that is 0, 1, 2. Now q you substitute. Theta 0 is equal to pi by 3, that is 60 degree. Theta 1 is 3 pi by 3, that is 180 degree. Theta 3 is equal to 5 pi by 3, that is 300 degree. Now first you have to do a straight line with an angle of, you have to draw a straight line with an angle of 60 degree, another straight line with an angle of 180 degree, another dotted straight line that is at an angle of 300 degree. So one asymptote, second asymptote. Here this asymptote is overlapped with the real axis. So we are drawing the asymptote. That is the fourth rule. Now next one is the point of intersection of the asymptote with the real axis is called centroid, is at s is equal to sigma, where sigma is minus sigma is equal to sum of real parts of poles minus sum of real parts of 0 minus number of divided by number of poles minus number of zeros. So the minus sigma means in this side. So in order to calculate sum of real parts of the poles, so sum of real parts of the pole is 0 plus minus 1 plus minus 3. Okay, so you are getting minus 4. This is one set, minus sum of real parts of 0. There is no 0, so it will be 0, divided by n minus m, that is 3. So when you are doing like that, you are getting it as minus sigma is 0 minus 1 minus 3 minus 0 divided by 3 minus 0. So you are getting minus 1.33. So you need to mark that point minus centroid, that is s is equal to minus 1.33. Okay, from that centroid you need to draw the asymptotes. Okay, I told the degree only, but from where you have to draw the asymptotes? To draw the asymptotes from the centroid. This is a centroid point, that is 1.33. From that you have to take a, that is around that you have to take a 60 degree first asymptote, 180 degree second asymptote, 300 degree third asymptote. The asymptotes are usually represented by dotted line. Now, yeah. So now we completed the rules. Now we completed the rules 5. Now, rule 6. Rule 6. Rule 6. The breakpoints, that is breakaway and break-in points of the root locus are determined from the roots of the equations. Roots of the equation dk by ds is equal to 0 and r branches of the root locus which meets at a point breakaway the r branches of the root locus which meet at a point or breakaway at an angle of plus or minus 180 degree by r. So this is the rule number 6. So in order to find that, the breakpoints are given by dk by ds is equal to 0. So how you will get that? 1 plus g of s into h of s is equal to 0. This is the characteristic equations. Now modulus of g of s and h of s is equal to 1. This is the magnitude criterion, and angle criterion already we come across. 1. So my modulus of g of s h of s, that is equal to k divided by s into s plus 1 into s plus 3 is equal to 1. Now k can be obtained by multiplying this with 1. So k is equal to s into s plus 1, s plus 3, that is s cube plus 4s squared by 4s. Now dk by ds, differentiating k with respect to s, d by d of s, that is s cube plus 4s squared plus 3s, that is equal to, when you are differentiating you will get 3s square plus 8s plus 3 is equal to 0. So this is a quadratic equations. So the roots can be found by s is equal to minus b plus or minus root of b square minus 4a into c divided by 2a. Okay. Now when you are doing like that, you are getting minus 8 plus or minus root of 28 by 6, that is equal to, you are getting two values. One is minus 4.51 or minus 0.451 or minus 2.28. But by using the previous rules, we come across that between minus 1 and minus 3, the segment are not a part of the root locus. So you cannot take this minus 2.28, and you can see here, as per the previous rules, minus 1 to 0 is a part of a root locus. So the breakaway point can be at minus 0.451. So you can see here at a minus, this point is nothing but s is equal to minus 4.51. Okay. Now, so this is the breakaway point. Angle of breakaway point can be calculated by minus 180 degree, plus or minus 180 degree by 2. That is, you can see here, it is at one point it will break away to two branches, and the angle is, you can see that minus 180, plus or minus 180 divided by 2, that is 90 degree. So here you are getting 90 degree. So this is, as per this, the angle of breakaway or meeting point, that is plus or minus 180 degree. Meeting point means if it is a 0, there it will come and meet. If two zeros, if two zeros are there, like this, you can see that. So here, here there is no zeros. In some other cases, if there is two zeros, in this case, there are one zero is here and two poles, another zero is in infinity. So here you know that it is the root locus are coming